Hi, welcome back. This video is on training your own machine learning model using a platform that is being run on Hugging Face. So you can create your own platform uh, as I'm explaining here and train, test, and even download your own machine learning model. So this is not about like how to create an application, but this is about giving an essence of creating an application, or the fact that you can create your own application and you can add your own machine learning models to this. So I have given like about maybe 3 4 examples. So you can add your own models and build some kind of a application like this, such that so it will be easier for you to work with the machine learning models rather than like always typing Python codes. But again, it's a matter of like how you choose to do this. So if you want to work in Python, always you can work in Python, or you can create an application and work like this. So here I'll just show you what this application does. So here this has a particular window to upload a CSV file. So here my CSV file is the iris dataset. So that is a famous dataset. So like here I list all the columns that is in the dataset. However, you may not need all the columns depending on your application. So I give this option to select the columns here. I need all the columns, so I'm selecting all the columns. But if not, you can choose whatever the columns that you need and submit selections. Once you select this, in the selected features, you can see this list. Now you can see here, sorry, this variety of our class name has come to the third position or the fourth position, not to the rightmost position, but we have to get it to the rightmost position. So that is because I have selected it before one of these other features. So I will select this in order. So probably this will work. Let me see. Yeah, now the variety is in the last page. So here, based on the order you select here, so you can change the order of the features which appears here. So I think the feature order doesn't matter for machine learning, but however, for us, depending on how we code, we have to have our class at the end. Right. So then this tab provides exploration of data. So whatever is in here, we can explore using certain options. I mean, you can create your own options using the code. I will give you the code. So far I have like a view shape of the data. So when I click view, it will show the shape that is 150 rows and 5 features or 150 instances, and view data types. So these are the data types. And if I want to list unique classes, number of unique classes should be 3, and these are the classes, and each class has 50 instances, right? So then count rows with 0 value. So if we have rows with all 0 values, so we may need to sometimes remove. So I'm going to check how many such rows that we have. So we don't have any. So if we want to delete, we can delete. Again, depending on your application, if you want to delete, you can delete it here. Here, and then count the rows with missing values. So if there are rows with missing values, so we can wave, but here there are none. But if there is, we can delete it. And then count the duplicate rows. Sometimes we may need to remove the duplicate rows. So wave, we have one duplicate row. So I'm going to delete that, and it says deleted. And if I wave again, it's been deleted. No? So that's all for exploration of data. You can add more options if you want. And then we'll go to pre-processing. So if I apply encoding wave, that means I'm encoding my the columns which are not numeric. So here, if you look at this, the class is not numeric. So in here, I'm making it a numeric value. So if I want to apply scaling, that means now these features are in different scales, right? Sometimes this may be some feature may be varying between 0 to 10. The other one may be from 150 to 200. So those are in different uh, values or different ranges. So because of that, we may need to scale them. So if we apply, everything will be from 0 to 1 here, right? But I don't want to apply scaling because at the pipeline stage, I'm going to apply scaling. So if we apply scaling prior to, sorry, division of training and testing, So there can be issues. So I'm not going to do that. I just wanted to show what happens when you do scaling here, right? And then test train, test train or train test split. So here, how much of data that we are going to use for testing. So here the standard I have set here is 0.2, that means 20%, but I can make it 25, 30% if I want. So let's say 30% of data I'm going to use for testing, and whether I'm going to stratify this split. So when I say stratify, that means when we divide data between training and testing, so training and testing should have same composition of classes, right? For example, if we have, say, I'm dividing this into, let's say, 30% testing and 70% training. So 30% testing in here is 45 samples. So say, for example, I have now, we have seen in my data, uh, let me see in my explore data. Mm, when I found the unique classes, right? You can see like we have 50, 50, 49, right? So randomly, when we divide this between training and testing, so out of this 50, maybe 45 will go to testing. So in that case, when we train, the data will be largely imbalanced, and when we are testing, the data will be like hugely imbalanced. So in order to avoid that, we are going to use this option called stratify. So when we stratify, training and testing will have the same composition of classes, right? So let's submit the split. So in that case, in the training distribution, we have like 35, 35, 34 of classes, and in the testing, we have 15, 15, 15 of, for each class, right? So it's a good distribution. Now here we have one less for this class than the other two. So if I want to oversample and make everything equal, I can do, or else I can go as no resampling at all, or we can go undersampling, such that all the the classes with larger amount of data will reset back to a smaller amount by randomly cutting down certain rows, right? So here, let's say we will do oversampling, right? So when I apply oversampling, it will be 35, 35, 35 for all the classes, right? So that is being done. Now data is ready, and then we'll build the model. So I'm going to apply standard scaling when I build the model. So that means I'm building the pipeline. Pipeline means several operations are combined together for to make it easier to run. So such that, I mean, once we build the pipeline, we can use the pipeline for in different places, so that we don't have to always do the same operations. So here, let's say apply standard scaling. For now, I'm not going to apply the principal component analysis. So you may already know principal component analysis. If you don't know, so principal component analysis is a way of reducing the dimensionality of data. So that means here I have 4 features. However, these 4 features may have redundant data, and most of the data may be able to represent using 2 or 3 features, right? Not the exact features that is here, but a linear combination of those features. So, okay, like, I mean, if you want to study more, just study about PCA or principal component analysis. I'm not going to do it here right now. Uh, let's say I'm going to use random forest. So you can see I have a KNN, random forest, SVM, and logistic regression programmed here. You can program others as you like. And so I'm going to build the pipeline. So when I build the pipeline, it says the scaler is standard scaler, classifier is random forest classifier for this pipeline. Now the pipeline is ready. Now we are going to train the model. So I think it's ready. If I go and train the model, now you can see the accuracy, F1 score, precision, and recall. All the parameters or the performance parameters are given here. And if I want to run a cross validation, I can run a cross validation using this one. So here for cross validation, number of parts that we are using is 5. So in this cross validation, it gives an accuracy of 98.1. So if I do testing, my testing results is 91.11, accuracy 9.07, F1 score. So yeah, so I have the results. And then I am providing here with the confusion metrics as well. And if I want to download the train model, I can download the train model here as well. So when I click the download model, it will prepare. So when I click this, it will download the model such that you can apply it somewhere else. And then we can't trust if this is okay without knowing the convergence. So I have given the convergence test as well. So when we run the convergence test for this, now we can see when the training sample size increases, uh, our training accuracy stays around 1, and here test or the cross validation accuracy comes close to 1 from below. So this is kind of converging. However, it looks like we don't have enough data for a proper convergence. However, this is good enough convergence. That is why we are getting around 91 point something accuracy, right? So I mean, depending on your data set, so you will have like proper usage of this convergence test. Sometimes you may see this line may go somewhere here such that there'll be huge gap. So that means there's no convergence. So it will go down as well when the number of samples increases. And at the same time, you can find out how many samples are required for convergence as well. So sometimes, like if you have more data, you may see when with less data, you can have the same performance, right? So, I mean, there are a lot of things that you can study regarding this convergence. So this is the application, and if you go to files, so this is Hugging Face spaces. I have shown you in my previous videos how to create a space in Hugging Face and how to add these files. Now I have add this app.py and requirements.txt. So in my requirements.txt, I have all the required requirements, and in my app.py, I have all the code segments required. So here the number of tabs are there. So the first one is the upload and select data, and the next tab is selecting features, selected features, and the other next one is explore data. So if you want to add more options for explore data, so you can add them here and write a if condition or else if condition here, and sorry, get the results of your exploration method, right? And then we have our pre-process data. That means oversampling and undersampling here, and then test train split is here. So if you want to do something in each of these tabs, you can edit this code. And if you want more help, you can even copy the code and paste it in Perplexity or ChatGPT and get more help. Yeah, so that is it. And so I hope you can copy this code, run it on your Hugging Face space, and see if this is working first. And if it is working, you can try to edit the code and see what you can do with it, right? So okay, so thank you very much. So this will probably be the last video of this type. And then if I have anything interesting regarding this Hugging Face spaces, I will show you. Other than that, so these are the basic things that you can do using Hugging Face spaces, and like for beginners of machine learning. So these are some kind of tools that you can build. While building these tools, you can learn Hugging Face, you can learn machine learning, and you can learn Python coding as well. Okay. So thank you, and see you in another video.